In the previous lecture,
we have started studying about CPU scheduling,
and we have seen a basic introduction to CPU scheduling. Now moving ahead, in this lecture,
we'll
be studying about CPU and I/O burst cycles. Now when we studied about CPU scheduling in the previous lecture, we understood what scheduling is in a very basic term. So what we actually mean by scheduling is the time that we are assigning to different processes for their utilization of the CPU. So we don't want the CPU to remain idle. When one process that was in hold of the CPU is waiting for some I/O operations to complete. So during that waiting time, we want the CPU to be assigned to some other process so that the CPU doesn't remain idle, and hence we can maximize the utilization of our CPU. So with regards to that, these are two important terms that we should know, and we should understand: CPU burst and I/O burst. So we will try to understand what we mean by CPU burst and I/O burst, and we also understand what is the CPU and I/O burst cycle. Process execution consists of a cycle of CPU execution and I/O wait. So when we studied about CPU scheduling, we already saw that a process can be in either of these two states. And what are those states? CPU execution state and input and output waiting state. So processes alternate between these two states. Now, what do we mean by these two states of CPU execution and input-output wait? So when a process has begun its execution, it is under the CPU execution state. That means it is making use of the CPU for its execution. So if it is in that state, we call it a CPU execution state. And after that, the process may need to wait for an input-output operation to be complete in order to continue with this execution. At that time, when it is waiting for an input-output operation to be complete, we say that the process is in I/O wait state. So these are the two states in which a process can be in once it has begun its execution. So processes always alternate between two states of CPU execution order: input-output wait. So when we use the term CPU burst, we should understand that what we mean by CPU burst is the time when the process is under CPU execution. So when the process is under CPU execution, we say that that is a CPU boost. And then when the process is waiting for some I/O operation to be complete, or when it is waiting, then we call it I/O boost. So in simple terms, CPU burst and I/O burst are nothing but the time in which the process is under CPU execution and I/O wait, respectively. So that is what we mean by CPU and I/O burst. So when a process execution begins, these are the stages it goes through. So process execution begins with a CPU burst that is followed by an I/O burst, which is followed by another CPU burst, then another I/O burst, and so on. So we see that when a process begins its execution, it starts with a CPU boost. That means this: under CPU execution, it is using the CPU for its execution, and at some point of time, it will need some input-output operations to be done. So at that time, it will wait for the input or output operation to be complete, and that is what we call I/O burst. So there is an I/O burst over here. And after the I/O burst is complete, that means after the wait for the input-output operation is complete, it will again use the CPU for its execution. So hence we have a CPU burst again, and then again it may need to wait for some input-output operations, and hence we have a input-output burst, and so on. This pattern will continue. It will alternate between these two states of CPU burst and I/O burst, and it will go on. So these are the stages that a process goes through in its execution. It is alternating between the two states of CPU burst and I/O burst. So remember the meanings of CPU burst and I/O burst again. CPU burst is when the process is being executed in the CPU, and I/O burst is when the CPU is waiting for I/O for further execution. That means when the CPU is waiting for some input operations to be complete, then we call it I/O burst. So that is CPU burst and I/O burst, and processes, they alternate between these two states during the course of its execution, and eventually, the final CPU burst ends with a system request to terminate execution. So once this pattern continues, and at the end, what happens is that there will be a final CPU boost. That means a final execution of the CPU, in which there will be a system request to terminate the execution offer process. So we have already studied abort process cancellation, and we have seen what do we mean by process cancellation and how process termination takes place. Now let us look at a simple example to see and understand the way CPU burst and I/O burst occurs in a process execution cycle. So here is a small diagram in which the alternating sequence of CPU and I/O burst are depicted. Here we assume that a process has begun its execution, and these are some of the operations that are performed during the execution of a process. So here we see there are some operations like load, store, and read from file. So these are the operations that has to be performed in the CPU. So the process requires the processor or the CPU for this to happen. At this time, the process is using the CPU, and that time is known as CPU boost. And after this operation is complete, the process is waiting for some input-output operation to be performed. So here it is waiting for input-output. And at that time, when it is waiting for input-output, it is not using the CPU, and at that time, we call it as I/O burst or input-output burst. And again, we see that after the wait was complete, after the I/O operation has been completed, there are some other operations like store, increment index, or a write to file. So these are operations that again requires the CPU or the processor. So at this time, when the process is doing this, with the help of the CPU, we call it a CPU burst. And again, similarly, it comes down and has to use some input-output operations. So it is waiting for the input-output operation to be complete. And there we have I/O boost again. And moving forward again, there are some operations like load, store at storage from 5, which is similar to this one. So we already saw that this is a kind of operation that requires the CPU. So this is again a CPU boost, and then it is again waiting for some I/O patient to be complete, which is known as the I/O burst. And this pattern continues. And until when will it continue? It will continue till the process is terminated. So when the process is going to be terminated, there will be a final CPU burst in which the system will request for the termination of the process. And once that is completed, this process will be terminated. And then the CPU and I/O both cycle for that particular process will be finished. That is what we mean by CPU burst and I/O burst. And here we have seen an example of how it happens. So as we continue studying about CPU scheduling, these are two important things that should always keep in mind. And whenever we use the terms of CPU burst or I/O burst, you should always remember what it means, as we have studied in this lecture. So I hope this lecture about CPU burst and I/O burst and CPU and I/O burst cycles were clear to you. Thank you for watching, and see you in the next one.